like I said, the visuals, I also am very visual. I have to, we were talking about this yesterday, I have to see it, I have to build it, I have to break it, and then I have to fix it, and that's how I know.
And then I will usually break it again,
and break
no
it again,
less than 100 times.
And then I'll break one of yours. And so, yeah, I mean.
That's okay, then I'm going to start breaking your stuff.
Especially
since I'm still learning EDA and Lambda and all that, but you can break containers. And
that's right, that's right.
It's perfect.
I think one of the key takeaways I would say on this is event planning is critical.
Yes.
These are the fundamentals of event-driven architectures, and I mean, it's so important. Events are so important, they're in the name. We talk about event-driven architecture, and it's important to plan what do those events look like. And I know Dave's going to come back later and talk about that, but it's critical to plan that out. And it's a great place to start at these bite-sized learning, these visuals.
Right. And I mean, just going along with that is I know that like when you're saying event planning, like it's in the context of EDA and event-driven architecture, but planning in general is so important as you plan your delivery and that end result, that end delivery of value to your customers. So the more that you can kind of put forethought into what the end goal is, the better outcome you're going to have. And as you said, the visualization, docs, I think there's even a whole serverlessland.com with learning and all sorts of different content for all different types of learning styles.
That's right.
Which is pretty great.
All right, so next we have developer advocate Ben Smith, who's part of our team, and he's going to be talking about building with serverless workflow at scale. Ben, welcome. Bill. I called you Bill.
You're being renamed. You didn't even know that.
Welcome to the table. That was a magic swap. That was awesome.
Yeah.
So it's just like Dave just.
Yeah, I'm hoping it was like Star Trek, where we just like evaporated Boydie and like dropped you in. Yep, perfect.
We turn it over to you, sir.
Thanks very much.
Yeah.
Hello, everyone watching around the world. It's been really nice seeing your comments come in, so please do continue to bring those comments in. This next session is building serverless workflows at scale. So just to give you a bit of context about why I wanted to talk about this particular topic, my name's Ben Smith, as the guy said, and I'm a principal developer advocate for serverless at AWS. And over the last couple of years, I've spent a lot of time building serverless application using step functions. So that means building with workflows. And that's given me the opportunity to speak to customers all over the world that are running step functions workflows in production, speaking about different challenges that they're facing and interesting patterns that they're using to implement workflows for their serverless applications. So this talk is really all about condensing all of that knowledge and learning into a 25-minute or so presentation on how you can use serverless workflows at scale. So I'm going to go ahead and jump straight into it. So the reason that I think workflows is a really good way of building your applications for serverless workloads is because when you start building applications with serverless and on AWS, essentially you're really leaning into this service-driven approach, right? You have multiple resources spread over one or maybe multiple accounts. Normally those resources is more than one, so it's not typically that you see an application consisting of just one Lambda function, for example, right? So the challenge quickly becomes when you have your application that's spread over multiple services, how do you then understand how the data is passed between those services? How do you visualize and understand and inspect and kind of see when an error is happening in your application? And this is a new challenge when you're building with this service-driven approach. And this is where step functions and workflows kind of comes to the rescue, I think. So this little example here that you can see on the screen is me building out a step functions workflow using something called Workflow Studio. So I'm able to select from hundreds, in fact thousands of actions for my workflow. Things like adding an object to an S3 object store or getting an item from a DynamoDB table. I can drag that into my design view and I can arrange it with conditional logic. I can add parallel states, I can add branching, I can create loops and I can catch and retry errors. And then I can click into the individual action and actually configure that action and how it will run. Step Functions is a serverless service, right? So it's pay per use, it scales automatically, there's nothing for you to provision or manage or patch. It's a fully managed serverless service in that sense. And it has this nice drag and drop interface, right, which you can see is I think one of the nicest interfaces that we have in the console on AWS. But of course, you can also build your workflows as code. And that's a language called ASL, Amazon States Language. And you can import your ASL into your workflow, or you can export. And that means you can add it to Git repositories and share it with your development teams, make pull requests on it. And of course, you can include that in your infrastructure as code templates to have a nice scalable way of building your serverless application as a workflow. But here's the magic bit, right? Step Functions actually natively integrates with over 250 other AWS services. And it does that by using the SDK for that service directly. So it's not running any Lambda function under the hood or anything like that. It's the service itself is calling that SDK action. So that means you have over 11,000 actions available for you when you build with Step Functions workflows. So I'm a big advocate of starting your next project using Step Functions. Maybe not every single project is perfectly suitable, but there's so many use cases where you can get a lot of added value by just starting with Step Functions. Typically, you hear lots of people at AWS say to understand how to build serverless applications, maybe start with Lambda, understand the event handler, the context object, understand how Lambda scales, and as a place to kind of upload your code in response to events, right? And then you'll hear people say add API gateway to create a kind of front door to that business logic. Then maybe add object storage or state with DynamoDB or S3. And then when you learn all that, you'll hear people say you can now orchestrate that in a Step Functions workflow. Well, I say come at that from the other side. Start with a Step Functions workflow and start dragging in those different actions as you start orchestrating them into a workflow. And here's why I think that's a great way to build your application, right? Let's go back to the very first day of you understanding how serverless works, and you want to get to grips with building your first serverless workload. And you're probably going to use Lambda because you're a developer and you're comfortable with code, right? So here's a simple Lambda application that simply gets an item from a DynamoDB table. So what do we need in order to do that? Well, the first thing we need is to bring in the AWS SDK. And then I'm going to build this in Node, so I've chosen my runtime for my Lambda function. And I'm going to bring in something called the doc client so I can interface nicely with DynamoDB, unmarshalling and marshalling data. I set up my params object, right? So this contains things like the table name, the partition key, and the sort key. And then I set up my query items function. So here I'm going to create a promise to get an item from a DynamoDB table. I'm going to put that inside a catch and retry block. And then finally, I'm going to create my exports handler. And to this, I have to understand what the event object is, what my context object is. I have to call my query items. I have to stringify the response, and I have to handle any errors. And then finally, I have, after 20 lines of code, I'm now able to get an item from a DynamoDB table. Now that 20 lines of code is 20 places where something can go wrong, right? Because it's my code. So how can we get added value by building this same workload as a Step Functions workflow? Well, this is what I want to show you, right? Simply, it looks like this. It's a workflow with a single SDK action to get an item from a DynamoDB table. And I can still configure the retry logic. I can still catch any errors and send that downstream to a dead letter queue. And what's great about this isn't just how this looks in a nice PowerPoint picture. It's actually how it looks in the service, right? So if I come back to these two workloads in a month, a week, or even later on in the day when I've been context switching and building other things, which two versions of this will be easier for you as the developer to quickly pick up, understand, maybe explain to your business stakeholders? It's probably going to be the workflow. Then, as I start sending executions to my workflow, I get this nice single pane to see all the failed and all the successful executions in one place. I can drill down into any one of those executions, and I can see the failure bubble up and inspect that nice and easily. These are things that are quite difficult to do with serverless applications, with multiple resources spread out across multiple accounts and domains, and probably multiple CloudWatch logs as well. Another thing I can do is I can step through each individual state in my workflow, and I can see what the input looked like before it entered the state and once it exited the state. Again, being able to kind of follow my data around my serverless application is a difficult task, and there's entire businesses that are set up to kind of help customers with this, right? Step Functions has it actually built into the service. OK, back to my version 1, my Lambda function. So I had this Lambda function, it's querying my DynamoDB table, and I'm happy with it because it's scaling automatically in response to requests. I don't have to think about managing those servers. And now I need my Lambda function, my little microservice, to do more things. So I'm going to create a kind of REST CRUD API, right? I want it to also update my DynamoDB table, maybe delete records in my DynamoDB table. So I go back to my Lambda function, and I add additional logic in there to perform those actions. I also have to add routing logic, right? So I know which one of those actions to perform based on the inbound request. And then I know that I need to put an API gateway in front to create a front door to my business logic with authorization and authentication. And I'm routing all those requests to my Lambda function. This is something that customers tell me they do all the time, right? Because they're happy with their Lambda function, they're happy with API gateway, how it's running, and they need to move quickly. But this is a little bit of a trap that customers get themselves into, because what they've now created is this kind of mini Lambda-lith. Why is that bad? Well, how can this be improved, right? Well, there's a few reasons. The first is I now have a Lambda function that's doing lots of different actions on my DynamoDB table. And each one of those actions has a different security permission associated with it. So my Lambda function becomes quite loosely permissed. I also can configure my performance and my timeout limitations on my Lambda function. Now, these will be different depending on what action I'm performing on DynamoDB. But because this Lambda function could be doing any of those actions at any point, then I have it quite loosely configured for all of those actions at the same time. What people often tell you to do to improve this is to split this out into 3 or 4 or 5 individual Lambda functions. So now you have each function doing an individual discrete action, right? Maybe I have one function to create a DynamoDB item, I have one function to update, and one to delete. This is good. I've got some good gains here because I've been able to take out all of that routing logic from my single function and put that into the configuration of API gateway. What I also am now able to do is to more tightly permiss each one of those Lambda functions with the correct IAM role, right? So my application is less porous, it's more secure. I can also configure the performance and the timeout limits for each one of those functions. So these are all good improvements. But what's the problem? Well, now I have 3 Lambda functions, each with very similar bits of code that are doing very similar things, but that's 3 times 20 lines, it's 60 lines of code where something can go wrong because it's functions that I've written. This makes things slightly harder to discover, harder to understand when there's a bug that goes wrong, and can be improved massively by this next pattern that I want to show you. So this is the REST Easy or the REST CRUD API using API Gateway and Step Functions, right? You'll notice in those Lambda functions I showed you, there's actually no computation going on. I'm not processing anything. I'm just moving data around and retrieving or adding something to DynamoDB. So why would I run compute when I'm not actually using any computational power, right? With this pattern here, I still have API Gateway to authenticate and authorize requests. Any valid requests I send on to my Step Functions workflow. The first step in that workflow is to decide which branch to go to next, whether it's a get, a put, a post, or a patch. And this will be all based on the inbound HTTP request from API Gateway, right? Then I just perform that individual SDK action, and I return the response back via API Gateway. Now, this is just as performant because I can run this as an express workflow. There's no code to manage at all, and there's no cold start time because I'm not using any Lambda functions in this. We built this, OK? Holly, in her keynote earlier on, mentioned this application called Serverless Espresso, which is a serverless application using event-driven architecture, which we built for multiple AWS summits around the world. And the idea was that you can use this serverless app to order a nice cup of coffee from your phone. And this worked great, right? One of the services in this application was called the Order Manager service. And it was a very kind of straightforward REST CRUD API that used Amazon API Gateway to forward requests or proxy requests onto a Lambda function, which would interact with the DynamoDB table to kind of update the state of each individual coffee order as it moved through our system. Now, we had some issues with this, right? We had some small latency issues. We found that every time we needed to add something to this service, we had to dig down deep into our application, find the Lambda function that we needed to update. We found issues with poor discoverability, and it was slowing down the speed that we could create new versions. So we created this instead, the Order Manager service as a workflow. So just like I showed before, we send every request to our Step Functions workflow, and depending on what that request is, we perform or we go down a different branch. Now notice we are still using Lambda in here, but we're using Lambda for actually computing something, right? So what that Lambda function here is doing, it's called sanitize order, and it's actually making sure that the order that's just been submitted is something that does exist in the workflow and is valid within that certain window, right? So we have to run some actual code for that. OK, I'm going to move on to some other stuff. We talk about running step functions at scale. And there's lots of different ways you can do this. But I have to narrow this down to some of the sort of fundamentals and some of the more interesting use cases. So the first thing to know is that you can send lots of invocations to a single step function workflow definition. And it will scale for you automatically, right? But each one of those workflows runs as a kind of single independent process. So what that means, if one of them fails, it doesn't affect the other executions, the other workflows of that same definition. We have something, a type of state in step functions called the dynamic map state, right? And essentially, this runs as a sub-workflow of steps within your map state. And you can pass to this an array of inputs. And what you're then able to do is run these sub-steps against that array, either single-threaded, 2 at a time, 3 at a time, up to a max concurrency of about 40. So here's a pattern where we've used that ourselves in the Serverless Developer Advocate team. There's this little website called serverlessland.com, which we built about 3 years ago. And the reason we built it was to aggregate all of the AWS blog posts that were getting sent out into one single point, right? So we built this workflow to do that aggregation. And we actually wrote a blog post on it to show how we did it. And this code is available for you on the AWS blog. This is the fan-out pattern, right? So the first thing we do is we run a Lambda function that gets data from an RSS feed to show every new blog post that was released the day before. That data creates an array of URLs with new blog posts, which we then send on to our dynamic map state. Now, concurrently, for every single item in that array, we scrape the metadata to create an object that gives us more information about each one of those blog posts. And then we save that metadata to GitHub, which is where we have our code repository for our static site. And then finally, when all of those map states are finished running, we then trigger a new build on AWS Amplify. And that's how we aggregate all of the content every day. We actually improved this since that version 1 by using the scatter-gather pattern, or fan-in, fan-out. Dave actually talked about a similar pattern using events in his talk earlier on. But of course, you can implement the same pattern in lots of different ways, right? So here, we still scrape an RSS feed, and then we go ahead and we invoke a Lambda function to get a data about each one of those blog posts. We create that into one single array of objects, which we then save to GitHub in one state. And the reason we did that is to reduce the number of state transitions inside our map state, because this runs as a standard workflow. And with a standard workflow, you pay for the number of state transitions in your workflow. So simply by moving that function outside of our map state, we reduce the number of state transitions, and our workflow is actually slightly optimized and costing less. What we found is that customers wanted more than a concurrency of 40 items, right? So what they were doing was quite cleverly embedding map states within map states within map states to get 40 times 40 times 40 concurrency, which is a pretty smart idea, but it's a pretty awkward way of understanding and debugging your application, right? So we wanted to help customers to get better concurrency from their step functions workflows. And so at reInvent, just past, we introduced this new distributed map state. So the key incredible thing about the distributed map state is you've gone from a concurrency of 40 to now a concurrency of 10,000 parallel executions, right? And the distributed map state actually plays really nicely with S3. So you can point it at an S3 bucket and say, invoke the map state for each item in that bucket. Or you can point it at an item or an object in that S3 bucket, say a JSON file or a CSS file, and you can say, I want to iterate over each item in that CSS file. Here's an example of where we've used this dynamic map state to show you some of what it can do, right? So let me just see if I can get this demo ready. So first of all, I'll walk you through it. This is a serverless GIF generator as a workflow, right? So the first thing that it does is it is invoked as soon as I drop something into an S3 bucket. That then starts the workflow. And it passes to the workflow the key, which is the name of the file that I've dropped in my S3 bucket, and also the name of the bucket. Then it invokes a Lambda function that uses FFmpeg to understand that based on the length of my MP4 movie file, how many GIF animations do I need to make for every 5-second interval? It then saves that array of metadata, if you like, to another S3 bucket, and then it enters our dynamic map state. And now, for each individual GIF animation, we run this Lambda function to generate a new GIF file and save that to another S3 bucket. And there, we are able to create a GIF animation for every 5-second interval of our movie. And I want to show you how this actually runs in reality, right? So we have a little demo here. If we can switch to our demo slides. So here is my workflow, and very similar to the image that you just saw in PowerPoint there. The first thing it does is calculate how many GIF chunks will be needed to generate, save those array of metadata about that chunk, like where does each GIF animation start and finish. It then loads that metadata in our dynamic state and then generates them and saves it back to S3. And what we get at the end is we get a timeline scrubber where we can look at every GIF animation and every 5-second interval. So I'm going to go ahead and run this, right? I'm going to upload a little movie. So this is just an MP4 movie which was taken at the Serverless Espresso booth during one of our reInvent examples. I'll just get this started, trigger that to upload. So this movie is only about a minute long, so it should create 12 to 15 GIF animations, right? While that's uploading, we'll go back to Workflow Studio, and we'll see what's happened. So once this is finished uploading, this will generate an event onto EventBridge, which will then, via a rule, get routed to my serverless workflow, and it will start a new invocation of my workflow here. So if I refresh that, I should see that pop in. We can see it's already running there. Maybe I'll zoom in a little bit for you. We can see that's already running. And if I step into it, as I mentioned before, we can step through each individual state and we can look at what the input was and what the output was as it passes through each individual state. So this input looks like an event generated from my EventBridge put action. Here's my Lambda function that calculates how many GIF chunks to generate, and we can look at the output of that. So here, as I mentioned, you can see the start and the end timestamp of each of those GIF animations. And then finally, that is then handed to my dynamic map state, right? My distributed map state. If I want to investigate my distributed map state, I can click on this little map run. Because basically, this is running as a separate workflow, if you like, right? So we can investigate this independently of the other states. And here I get a roundup of how that worked. So I can see that it actually ran 12 times. So I can expect 12 GIF animations. None of them failed. And I can drill down into each one of those 12 executions and see exactly what the data looked like when it entered and exited, right? If I switch over to my destination S3 bucket, this is where all the GIF animations are saved to. If I refresh that, here's the directory. And here's all those individual GIF animations, right? Finally, if I then go to my front-end application, I can show you what it looked like. Here's the original file, and here's my timeline scrubber. And you can see there's a GIF animation at each interval of my timeline scrubber. Let me just set that. There we go, taking a while to load. So here's my GIF animation at 35 seconds. Here's my GIF animation at 40 seconds. Now, what's magic about this is it doesn't matter if the movie that I uploaded was 1 minute or 8 hours, because you get a single invocation of each of those GIF generating Lambda functions for every 5 seconds that is invoked concurrently. So I'm managing my Lambda concurrency using my distributed map state. So that's the sort of power of dynamic map state or distributed dynamic map state and Lambda. If I switch back over to my deck, I'll show you where you can go to read on a little bit more information about step functions. So we have this thing called the Serverless Workflows collection on serverlessland.com. All the patterns that I showed you today are actually already on this collection, and well over 100 patterns that have been added by serverless experts at AWS and customers as well. You can browse the visual image of the step function workflow. You can look at the infrastructure as code template, and you can even see the ASL definition, which is really nice for helping you debug any kind of challenges that you fall into when building your own workflows. And so with that, I'll say thanks very much. Hand back over to the guys.
Yeah, great job, man.
Thank you.
Yeah, very cool.
Yeah, I personally learned a lot. Like, I'm still learning a lot about step functions, EDA, and Lambda. And I mean, the GIF animator and just how quickly that works is pretty cool. I know, Eric, you and I were talking.
Yep.
And would you recommend starting with step functions, starting with Lambda, starting with EDA? Like, what's the best place there?
Well, if Ben says it, I'd do it. I mean, that's just,
Yeah,
Ben,
I'm still here.
yeah.
Sorry, I'm like cutting
Let
you
me
out of the
validate
conversation.
what Ben has said. And computator, was that the word you used?
I made up a new word there.
Yeah.
Yeah.
So
See if it sticks.
So now let's hopefully that it's going to get added to the dictionary there.
Yeah. So, well, I think what's important is, I agree with Ben in starting with step functions.
Right.
He's not, and I think it's funny because I've actually had people say, "Are you anti-Lambda?" No, I'm not anti-Lambda, but I believe in the right tool for the right job. And most applications start with routing. I know you said
Not
routing.
routing.
But,
You mean routing.
and routing.
Yeah.
Most applications start with routing data around, and then when you need that computational power, then we invoke the Lambda function. I'm very much for Lambdas. I'm just a big fan of using right tool, right job.
Yeah.
And so, yeah, I think it's a brilliant place to start. I'm the same way. I now start with step functions, especially with the synchronous execution. That just opens up a whole new world.
That's my talk later on today, right?
Oh,
So I
look at
just
that.
did it, so you
Yeah.
can take a break.
You no longer
I'll
need
be
to.
back, yeah.
But it's funny,
All right.
anytime we talk about the right tool for the right time, I do just quickly like to think of, like, if you think you have a toolbox, like, depending on what you're working on, you may grab a screwdriver, like that may be Phillips, that may be flathead, you may grab a wrench, and it's kind of the same thing. Like, am I going to grab step functions? Am I grab Lambda? Am I going to grab containers?
Right.
And it just really gives you that universal toolbox, and that's a good way to look at AWS there.
All right, Ben, thanks a lot.
Thank
we
you.
appreciate it. Yeah.
Cheers, thanks.
So.